All right, I'm going to record this for people that aren't here. This is your day one prep for calculus. When you take calculus one, all that algebra and trigonometry stuff that you thought was like boring and unimportant becomes like a useful tool. This is where you go to find out if you actually knew algebra. So hopefully,
Oh, they don't know algebra.
yeah.
You think you know algebra? You don't know algebra.
You don't know.
Suck. You suck. Oh yeah. You suck. You suck. You all suck in algebra, and that's just period. You know.
And this is the same instructor that wants you to continue sucking by telling you to use AI to learn.
So I'm gonna have to separate.
Sorry for the going on. I don't want to join this.
I see, when I said there was gonna be heckling, I thought he was gonna start with me, not the crowd. God. Red just goes for the students' throats. All right, so let's do some real number stuff. Like stuff that's, you know how to do, but like order of operations, it matters. You may know it as PEMDAS. Some teachers, a lot of teachers teach it as, please excuse my dear Aunt Sally.
People eat meat, die in supper.
But I do not have an Aunt Sally, and if I did, she probably wouldn't be dear. So I like to instead use, please excuse my dumb ass sibling. Most of us have a brother or sister, not everyone. If this doesn't apply with you, stick with whichever one you like. This is where Dr. O is going to tell me not to use words like ass, but hey, you're all adults. Or if you're not, you're about to be
Word
one.
for a donkey.
Yes, your donkey sibling. That's even worse. What are you saying about their parents, Dr. O?
Oh, that wouldn't work either.
All right.
It'd be DD, because then you would confuse yourself.
So we got something like, as a reminder, this is parentheses or grouping. Any grouping symbols, parentheses, brackets. If they're feeling crazy, they'll use curly braces, but a lot of that times that's reserved for set notation and stuff like that. Absolute value signs fall under the please. This is for exponents.
If we could see them, we're doing enough.
Was I off screen? Is it? This pen is not showing up well, is it? Oh wow, it is off screen. Y'all say something. Don't let Red be the
Say
one.
something.
I know. Right when you did.
This is amplifying.
Thank you. Why is it like that?
What are you, like new?
Yeah, I totally just don't know what I'm doing here. Where's the autofocus? There it's focusing. Okay. M is for multiply, and D is for divide. And these two are on the same priority, so it's left to right. And A is add, and S is subtract. Also same priority, so left to right. I recommend not changing things as you go down the page. It takes up more work, but like if you're doing stuff for a calculus test and you're skipping steps because you're doing them in your head and you pull a red one and make a mistake, the teacher's not gonna know. He's just gonna think, or she's gonna think you don't know what you're doing. So write down everything. I'll do the parentheses first, leaving and copying everything else down. 3 minus 5 is -2. 6 minus 9 is -3. At this point, this is multiplication. And so what comes next is exponents. Negative 3 squared turns into positive 9. And so multiplication and divide, there's only one. Negative 4 minus 9, we get negative 13. Basic stuff here. And hopefully this is nothing new. We'll do absolute value of 5 minus 9 minus absolute value of 4 plus 2. Absolute value is a grouping term. We do what's inside first. Don't just go applying the absolute value right away. 5 minus 9 is negative 4. And then 4 plus 2 is 6. I'll go over the actual formula for the equation, the piecewise function for absolute value in a little while, but for now, we're just going to treat it as make everything inside positive. 4 minus 6, and we get negative 2. Absolute value represents the distance from 0. So again, hopefully nothing new. If you are working on something separately, hopefully you are. If this is stuff you know and you have a question, raise your hand, and Redden will be happy to assist you. He's looking bored, and if you keep him busy, he won't be an ass. That's not a promise I can make, but I think it will hold true. Those are pretty basic. If you've forgotten how to deal with fractions, let's talk about fractions. We've got 5/8 times negative 4/7. When we do fractions, the things on top, the numerators multiply together when it's multiply or when it's multiply, and the denominators, or the things on bottom, multiply together. This ends up being negative 20 over 56, which reduces. It's easier to reduce these rather than multiply them all the way through. Reduce here. 8 is 4 times 2, and this is 4 times negative 1. So the 4's can cancel, and we get 5 times negative 1, which is negative 5, and 2 times 7, which is 14. So that will simplify to negative 5/14, or reduce to negative 5/14. So multiplying, and it does the numerator times numerator, top times top, and bottom times bottom. Do I have a division one? I do not. If we were dividing by it, we can rewrite this as multiplication if we use the reciprocal of the second term, or flip it over. These two are equivalent. And this one we can solve. This is 4 times 20 over 5 times 3. 20 is 5 times 4. 5's cancel. They leave behind a 1. I didn't do that up here, and I should have. It's important to know they leave behind a 1. Because if you cross off everything on the numerator or the denominator, there's not a 0 there, it's a 1 still. I've seen Calc 3 students make this mistake. So, wow, you're feeling guilty? He immediately points at himself and says, "What, me?" No one said it was you, Weaver. Not everything's about you. It should be, I agree.
Why did this guy?
It might have been Carlos. No, I don't think it was, I don't know, I don't think it was your guys' class. So that's how multiplication and division of fractions work. Addition and subtraction is a little bit different. When we're adding or subtracting fractions, we need a common denominator. The bottom has to be the same. So The quickest way to do it, although not the best way to do it, is to take the opposite, or not the opposite, the other denominators and multiply it by it. I'm gonna multiply this by 6 on bottom and this by 4 on bottom. If I just do that alone, that's gonna change the value, so we use the same value on top of each of these. 6 divided by 6 is 1, so I'm really just multiplying by 1. I'm not changing the value. And same here, 4 divided by 4 is 1, I'm not changing the value. But now we have negative 18 over 24 plus 20 over 24. And now we can add or subtract if that was subtract. When we add or subtract, we only do the numerators. This turns into negative 18 plus 20 over 24. Do not add the denominators. Do not do 24 plus 24. This will get us 2 over 24, which is 1 over 12. If you have a bunch of fractions, then this is not the ideal way because this may not be easy to simplify. Another way of doing that same one is we're going to find the least common denominator, lowest common denominator. 4 and 6. 4 is 2 times 2. 6 is 2 times 3. If you make a little table with unique elements in each column, unique factors, the LCD will be a product of what's left over. I got a 2, 2, and 3 is 12. I want to have a denominator of 12 when I'm done. The 4 is missing a 3, so I'm going to multiply this by 3 over 3. The 6 is missing a 2. I'm going to multiply this by 2 over 2. I've got negative 3 times 3 plus 5 times 2. Negative 9 plus 10 over 12 gets us our 1/12. Granted, not the fastest way of doing this for 2 fractions, but if you've got like 4 fractions you're doing and you don't have a calculator to do it real quickly, that will leave it in fractional form. And sometimes doing by hand is faster than pulling out your calculator.
Who's done 3 plus 3 on their calculator? 3 plus 9.
I think it's.
I see you doing something like that in my class, I'm all over you like a math teacher.
But if it's an exam, I don't trust myself.
You don't trust yourself. It's gonna be the square root of 25.
I'm like, I'm pretty sure 5
We're all
plus 5 is
depending
25,
on.
but.
Just to be sure.
Just to be
Seven, you know, 8 times 7.
I've done this so many times, but it's gonna.
I'll be honest, in Calc 3 exams, I've seen the following things. I've seen an answer left as square root of 1. I have seen square root of 0. And the best one was square root of 0 over 2. And they were openly ridiculed. I put the test up on the screen. Their name wasn't shown, so I wasn't blasting the student. But they know who they were. Are you worth confessing?
Look, it wasn't me, but during an exam, like, you think differently.
It's true.
Both David and Carlos in the back took Calc 3 with me. They can tell you I'm not lying. I do shit like this.
It's a free for all after the exams.
But I will ridicule you if you, but I won't point at you or name your name.
Then you got 20.
But I will, of course I dock points for stupid shit like this. Because it's not simplified.
Correct.
It's not simplified.
That's right, yeah. Next time allow calculator.
But it's only partially right. All right, now that's the basics for order of operations. Simplifying algebraic expressions.
You're off the charts again, there you go.
Calc is short for calculate.
We've got negative 5x plus 3 plus 4x minus 9. called like terms, things with the same variable, with the same coefficient. Not coefficient, same exponent. Variables with same I keep saying it. Same exponent are like terms. And the numbers together, without them, this is technically the same thing. When we get to exponents, you'll see why. We put them together. Negative 5x plus 4x. We can actually rearrange them due to the commutative property of addition, but only teachers like Redden expect you to memorize stupid names and shit like that.
Don't do that, that's horrible.
Just add them together. If you've forgotten how or why it works, we are adding the coefficients or the numbers in front. Negative 5 plus 4 is negative 1, and 3 minus 9 is negative 6. When we have a coefficient of 1 or negative 1, we don't put it, so that will just be negative x minus 6. I like square root of 0 over 2. That was my personal favorite.
It makes it seem like you know what you're talking about, you know?
To anybody that doesn't know math, it sure does. That's a basic, simple one. Something even Redden can handle teaching. Let's kick it up a notch. We've got 5 times 3x minus 4, and then negative 2 times 7 minus 5x. We want to distribute to each thing. 5 times 3x is 15x. 5 times negative 4 is negative 20. When we distribute the 2, we want to distribute the negative as well. Negative 2 times 7 is negative 14. And negative 2 times negative 5x is 10x. Now that we've gotten rid of the parentheses, we can group together like terms. 15x plus 10x is 25x. Negative 20 minus 14 is negative 34. Any questions? Good. I was hoping there would be no questions. I can't handle questions. I'm just reading what Redden wrote for me. Next one.
Does Redden know that you self-taught about him for your class as well?
He has to. There's enough snitches among you students that someone's told him. I'm sure I've told him. Okay, this is not negative 7 times 2 squared minus x squared. What it is 2 minus x times 2 minus x plus 5. Which means we have to distribute, or FOIL as you might have learned it as. 2 times 2 is 4. 2 times negative x is, my green pin's already dying. Negative 2x. Then we do these two, that's another negative 2x. And that is positive x squared. Notice I didn't just write out the parentheses of what they were multiplied to. I still have the negative 7 and 5. It's a good practice to do because you'll forget it. You'll get distracted. Your phone will go off. You'll get a car alarm. You'll lose some stuff. We can group what's inside. 4 minus 4x plus x squared. We'll distribute down. Negative 7 times 4. Negative 7 times negative 4x. -7 times x squared. And finally, we want to write that this is a polynomial. We want it in descending order because we read left to right. So we're gonna put the variable with the biggest exponent first, and the exponent's gonna descend or go down on each step. Hopefully, this is just a refresher for you. Again, if you're not working on this, you're working on the ALEC stuff, raise your hand if you got a question. We have professors in the room that are willing to help, and David and Carlos are actually getting paid to help you guys right now. So don't let them think that they're just sitting and doing nothing, they're here to help you. They presumably know what they're doing, I mean, I will say they know what they're doing because they passed my Calc 3 class with A+, I believe both of them. I know Carlos did, I think Weaver did too.
Are you teaching? Okay.
Next spring. All right, a little geometry. So here we're gonna find x. Couple things to know. Degrees that go from, like make a square in the corner, this is 90 degrees. And if it goes all the way around, not all the way around, does a half circle, this is a supplemental angle, it's 180 degrees. What?
Myself useful.
Thank you, Vanna.
Being Vanna White today.
AI would do a better job.
So that would mean this angle here and this angle here, I don't know what that is, we'll use question mark. No, we'll use Professor Redden's face.
All this.
137 degrees plus Professor Redden's smiley face has to equal 180 degrees. Subtract 137. What do we get, 43?
So how much trig do we need to know for calculus?
A lot,
Like when we start.
enough.
Yeah,
for quantity.
can I pass the class if I don't know any trig?
You're gonna have a hard time passing class without any trig.
Learn along the way.
There's enough trig in there.
Once the graph stuff, there's a lot of
Can I learn trig
page
along the
and
way?
page and procedures and things.
No, there's trick.
There are, you can, but it takes a lot of work. There are students, I think,
I did.
Carlos did, yeah.
I didn't use the
You
trick.
didn't know the like of trig and you passed calculus.
Do you need another trick?
It can be done.
Yeah.
I mean, I think that you
You
just
just
learn
need
along the
AI.
way. Like, it's what a problem.
Well, that's a,
I thought that Calc 1 was like really
Now you need enough
algebra
trig to
focused,
pass
and
it.
Calc 2 was like trig.
An application of derivatives.
This is why we didn't let Redden have the monitor, because he derails shit.
well, because that's your concern, right? It's like you see that trig and you're like, holy crap, I don't know any trig, how much trig do I need for calculus? That's what you're thinking, that's my superpower.
It might be a superpower, sure isn't teaching. All right, so, then we have that doesn't find x, we were looking for x. The angles inside a triangle add to 180. 180 degrees. And the square represents 90 degrees. So we have x plus 90 degrees plus Mr. Redden's face, which turns out to be 43 degrees, equals 180. And what do we get? X is 180 minus, what is this, 133 over here? I'm running out of room, and I do not want to grab another page because I'm a slacker. We subtract 133 and we have
47.
47, right?
Circle the answer. Okay, so let's play You're the Teacher. You're the teacher, and the student turns this in. Can you read that?
No.
I can read that. I
Is it an
can
enormous
understand.
mess with the answer circled in the middle somewhere? You do that? Do all your work all over the place, a huge mess, and then the answer in the middle?
That's
why you're in there.
Right.
I want to see that clearly laid out, give yourself a lot of room. 'Cause I have to read it, and if I can't read it, it's wrong. Just because it's circled in the middle doesn't mean.
The circled answer is only worth 1 point out of however many points the question is. The work is the majority of, for any good teacher, the work is the majority of the grade. So a better way to do this, as Mr. Red pointed out, this is garbage. What I did was garbage. You should do this in an organized manner.
So yeah, in college, you have to be a little careful. You know, college is a different story than high school. Your teachers are gonna be reading your nonsense, actually.
Do it in order.
Turn it in nice, you know?
Maybe show some work, even showing the subtraction.
I mean, you could use the S instead of smile. Oh, that's it.
No, that's Professor Redden's smiley face. And now, if you're trying to preserve paper and don't want to keep going down, then do some shit like this. I wrote percent. That is a solid, yes, please give me full credit. What I did on this page was garbage. If you've forgotten how radians work, a circle has 360 degrees. It also has 2 pi radians. So pi is 180 degrees. Pi radians is 180 degrees. And you can actually use this relationship as a conversion thing. So if we have 180 degrees over pi, we can start with radians and end with degrees. Like if I have 5 over 4 pi radians, and I want to convert it to degrees, I multiply by 180 degrees over pi. Pi cancels, this reduces to 45, this is 225 degrees. We can also go from degrees to radians by flipping that upside down. Doing pi over 180 degrees. So if I wanted to do that, let's say we're working with 135 degrees and I want that in terms of radians. I'm going to multiply by pi over 180. This is, let's see, 3 times 45. And this is 4 times 45. So this ends up being 3 pi over 4. Radians are unitless. You do not need to list them. They are usually identified in the context that they appear. But it is a measure of an angle.
I don't know if you're, when you're gonna stop lecturing, I'm Tom.
You want to introduce yourself?
Yeah, sure. Hi, everyone, I'm Tom, I'm also an instructor here, so if you need any help, I'll be glad to help you guys. So this is just calculus preparation.
Yeah, we're covering algebra and trig
Okay.
in the next couple weeks. And they're all working like on a program they took a test that narrows it down to what they don't remember how to do. So they're all gonna be at different stuff.
So it's making me do volumes of spares, like I remember all.
Do I need access to Alex with my personal account or not really?
No, but if you'd like it, I would.
4 by 3
Yeah,
bars,
you know,
like
I just help them with whatever they need.
It's making me like 6.7.
This is so frustrating. I don't know how to use this.
Alex,
Yeah, it's Alex.
I got like.
if you don't remember how to enter something on Alex, remember there's a question mark in the upper right that you can hit and it's called Tools Help. It'll show you how to enter the answer. I miss my green pen.
I didn't read it like 7th grade.
I brought a spare green pen because I'm clever like that. If I'm going too fast, let me know. I'm assuming this is review for everybody.
Yeah, exactly. It's just not.
Find the missing, or nope, find the area of the triangle.
Right,
And
because
this one's in
this is equal.
What's the formula for the area of a triangle, Mr. Redden? Do not use Heron's formula.
Root of the semi-perimeter times the
Yeah.
semi-perimeter minus A times the semi-perimeter
I
minus
do that too.
times the
I do that too.
semi-perimeter minus C. How do you know this?
Because I'm smart.
Because you took computer science.
Come on, like that was.
You had no
This
idea.
motherfucker really mean
It's
anything.
Ron's formula.
Up top.
You took my class.
We do that.
See, that's why I say fuck that guy.
Something from Mr. Redden.
Yeah, something.
You can do it that
So
way.
the one he gave you is Heron's formula. The area of a triangle is square root of s times s minus a times s minus b times s minus c, where a, b, and c are any of the 3 sides. Well, no. The 2 legs are a and b, and this is c. And what's the semi-perimeter?
The perimeter divided by 2?
And s equals 1/2 the perimeter. This is not a helpful way or the quickest way to do this.
It's only been around 2,500 years, so if
Doesn't
you
mean
don't
it's
know it, you got some catching up to do.
Or the other one you might remember, 1/2 base times height.
Well, there's that.
But I don't want to use this as a base because then I would have to figure out a height. And I don't want to do that. I mean, we could.
Wait, no,
That's even more trig.
no, you can.
Or we could just reorient the triangle, right? This was the 20 centimeters, 20 centimeters, 12 centimeters. I know. I was teaching.
Not bad.
There's a method here.
Did they seriously give it to you upside down like that?
No, he made it.
Yes.
They gave it to you upside down?
Yeah.
Were they trying to like mess us up or something?
I want you all to know.
I asked that to the team.
Now, this is great. This is great because Mr. Red in his old age does not remember this.
Yeah.
When I did the math jam 5 or 6 years ago, when he couldn't do it one summer, I inherited his Math Jam booklet. I've taken this stuff and rearranged it, but I'm lazy. I didn't review any of
I
these
made that
problems.
question?
That is a Reddit problem.
Oh, shit.
Kind of matters for the brain. Well, imagine if you were to flip it.
And now, height, we'll call that height and we'll call that base. Area equals 1/2 times 16 centimeters.
Did you complain about one of your own questions? I think I just did.
He did.
That's what he was like, that's what he was saying.
It's the glory that is Reddit. Now, you might have left the centimeters out when you're doing this, but if you did, there's a chance you might have fucked up the units. Leave the units in there, because it shows us that we're gonna have 8 times 12 is what, 96? And centimeter times centimeter is centimeters squared. And if you left the units out, you might have just said centimeter. Or not even had units at all. So you can put the units in the equations, and they'll still work.
Dr. O, who does the engineering classes, he insists
Oh, there you go.
with the,
This isn't just math teachers being prickly bastards.
in math, they don't really care so much, but in science, it's important. They tell me.
In math, it is important, just maybe the pure math teachers don't care.
Figure out this Alex, I tried doing the question.
So the other thing, if you wanted it to do the other formula, let's do the other formula real quick. Perimeter, what is perimeter? P is for perimeter. What is perimeter on a shape? What? It's the distance around the outside, right? Perimeter is distance around the outside. So we can just add that up. For a triangle, it's A plus B plus C, if we label the edges A, B, and C. So we have 16 plus 12 plus 20, which is 48, and these, I didn't do it, centimeters, centimeter, centimeter, so these are in centimeters. Perimeter is 48 centimeters. That means S, the semi-perimeter, is 1/2 P. It's 24 centimeters. So area using Heron's formula. We have 24 centimeters times 24 minus A, 24 centimeters minus 16 centimeters. And then 24 minus B, 24 centimeters minus 12 centimeters. And 24 centimeters minus 20 centimeters. I'm using the units because it matters. I tend to put a little drop down on the radical sign, tells you when it ends. Andy. What do we have in here? We've got 24 centimeters times 8 centimeters times 12 centimeters times 4 centimeters. I guess I don't need all the extra right there. And when we work this all out, we are gonna get 96 centimeters squared. Presuming I didn't screw up the other formula. There is a difference in these two formulas. The way I use 1/2 base times height is really only useful for right triangles because it has a right angle and then we can do this. Otherwise, you gotta figure out what a height is like this to do 1/2 base times height. And that takes a lot more work. Heron's formula is good for any triangle.
Which is
Doesn't
why
need to
we
be a
do it
right
in-
triangle.
We do it in computer science because it works for any triangle and you can code it up only once. And
Right,
it always works. But it's kind of like a lot of work.
it's not. It's not a lot of work.
I mean, it's, if you're doing it by hand,
We just have generative AI do it.
1/2 base times height, but when you do it programmatically, you definitely want to use Heron's.
John's going for the throat.
Jugular attack. All right, you guys ready? Was that fun? Are we having fun yet? You're like, ooh, geometry, ooh, shapes.
Love that,
Geometry is great.
love that.
Geometry is the way math used to be.
Don't be a kiss ass.
It's real, man. Real, man. Do stuff.
All right, next one, find the perimeter and area of the following figure.
Before we go on, do you have a recommendation for a calculator that's good for calculus at CRS?
Casio.
Which calculator do you like?
All the way.
If you're gonna buy a calculator tonight,
I actually carry it.
oh, come on with that one, this is
That
my
is-
favorite.
Bro, Casio all the way.
Casio.
Casio TIs? Get that 1980s.
What is the number on your Casio?
Mine is a FX 300 MS.
991DX.
You do not, the more buttons your calculator has, the less useful it is. Cause there's a lot more fucking shit to
No, it's like
learn.
15 bucks.
That one's only $15?
Yeah. Like find it online.
That's the classic one.
Yours has too many buttons.
I mean, does it do
It
fractions?
might have
It
a,
does fractions, it does,
So does this.
It does mixed numbers.
but you, let's be honest, do you really need to do fractions on a calculator? You don't. If you're going into calculus, you should be able to do that shit by hand easily.
Yeah.
When we took your class, you said,
Anybody else have one?
This is great.
You like that one?
My favorite.
This is the one I like. Got the good eyes.
I suspect they're all relatively similar.
Yeah.
They do the same shit.
Mine has the
well,
same amount
let's
of
close it,
buttons as
you
your
have to learn how to
kids.
use it. Like,
Right.
So, what's your recommendation for calculus? Seriously, they're gonna take.
The
calculus.
cheapest calculator you can get that has more than addition, multiplication, subtraction, divide.
You need sine and cosine. You want the fraction button. You want the fraction button.
Yeah.
You can do it.
If you're a
You want the
loser.
Fraction button is good.
The fraction button, see, I can admit it, I like Taco Bell too, I can admit that. Own it.
But is it good for you? No.
Own it. Taco Bell's not good for you, that fraction button's not good for you, but it really does help in calculus.
Or you can get better at fractions and never have a worry.
No, sometimes the fractions are ridiculous, sometimes they're
Yeah,
like
that's true.
enormous, it's like stupid. I don't know, I like this one, but you're the calculus teacher, so I don't know.
Well, there's 3 professors in here. What's your vote?
Get the FX.
My calculator, my phone, that's all.
You can't use your phone.
I know, but I'm just saying.
Do you think it needs a fraction button?
Yeah, I have a calculator.
I got mixed numbers.
Everything by hand.
So 2 of 3 professors tell you it doesn't need a fraction button. Although it is helpful, you start, anything you have on your calculator, you start becoming too reliant on,
Yeah,
and then your brain power goes down.
don't buy the calculator that does the work, the calculus, they're expensive, they're like $100, and they actually can do the algebra and the work and stuff. They're not worth it.
They're not your friend.
Well, they're not your friend, but they're really not worth it.
The ones that you can like code on, really?
And also the ones that do graphing, probably not worth it, the $100 graphing calculators.
No.
Because you're not gonna be able to use it maybe, and then, your phone, you know, you can have your Desmos, you can do that.
Right, in any real situation, you would have your phone with Desmos to be able to do graphing.
So go
Don't buy
for
a graphing
cheap,
calculator.
if you wanna buy one, go for cheap. 15,
Cheapest
20
one.
bucks.
Cheapest with sine, cosine, and exponent, square roots on it. You don't really need more than that.
You do need one though, right? I mean,
Yeah, I'm gonna say yes.
I'm gonna say yes too, I think.
There are some numbers you do not want to square.
Yeah, or take the cosine tangent.
Right,
Like she said, they can use their
Natural
phone.
Yeah.
Natural law.
if you're trying to find the radian equivalent of 58 degrees, you're gonna want a calculator.
It's nice to have the combination of permutation buttons.
Oh, yes. the
Yeah, yeah.
Statistics function, super
Which
important.
shows up as NCR on my calculator.
I think though, if you get one with sine and cosine, it will have the statistics stuff on it.
They usually do.
Mine has a distribution.
Ooh,
That's pretty cool.
that is cool.
Like a function.
That's way too much work.
You think
If you need the distribution button, it's much quicker to type that shit into Excel or
Desmos.
Desmos and do it quickly there.
But it's good to have, right? They have the normal PD, the
Is it?
normal CD, inverse normal.
Do you know how to use it?
Somewhat.
No.
I haven't had to use it.
That sounds like a no, so it's not a useful
I
button.
haven't had to use it, but it's there in case I do need it.
And Redden derailed my presentation again.
What you could do too
It is helpful, I agree.
is bother your parents for a brand new iPad because COS teacher says you need a new iPad.
I go like this.
I wouldn't go iPad, just use a laptop. iPad is harder for programming if you want to take a programming
I
course.
understand. Okay.
I definitely discourage iPad.
Really? I wouldn't say discouraged, but.
If you want to take a programming course and it is an elective in like a lot of the STEM fields, the iPad is not programming friendly.
Maybe you get an iPad if you have that.
You can have a tablet that is a Windows-based tablet that you can write on just like an iPad. It's called a Surface Pro.
That's
I
expensive
need
though.
to.
Yeah.
So is the iPad. The iPad is more expensive.
I got this for 450. That's
The iPad will last long.
Oh, you can check them out?
Yeah.
Oh, yeah.
I got the latest one.
Their batteries are out.
Have fun programming on the iPad.
No, I have a laptop.
And how much fun did you have in programming?
Oh,
That's 'cause I don't have.
It's not about the fun of it, it's about the doing it.
The older
I see some people taking
The Surface
notes on
is
their
a good
iPad.
choice, the pursuit.
Oh, yeah, and like.
Apple is always more expensive than its PC equivalent. I've yet to see it the other way
And then you
around.
actually write on it and fill it in.
Unless you find Apple
Yeah,
on a sale
that's
or
the
on like
reason why I
eBay,
want
someone selling their used one.
I got this through Black Friday.
That's a sale.
Yeah.
All right, so we want to find the perimeter and area of this figure. And it's an odd shape. It looks like what?
Oh, square and.
Salt shaker is one answer. I was thinking basketball court, but salt shaker works. This is I wouldn't say square,
Square.
but it,
Half circle.
I still wouldn't say square. I would go with a rectangle and half circle. Squares have the same side.
It looks like a square.
Yeah, all squares are rectangles, not all rectangles are squares.
So this is really two different shapes put side by side. This presumably is a half circle or semicircle. If Professor Jones knew how to draw a circle better, that looks more like a D. Let's see this.
I got that as a question.
Oh, and for pi, use 3.14 for pi.
This used to be 32.
Oh, are you getting this from Alex?
No.
Oh, I got that.
Now, Reddit might have got this from Alex, I don't know.
There was a limit here? Like the last one is this, it was a limit.
So the rectangle, this is 6 inches, this is 10 inches, means this is 6 inches, this is 10 inches.
I know one side's.
And it means this distance here is 6 inches.
Everything else is box.
So maybe we need the formulas related to these real quick.
The boss is here.
Yeah.
Who's the
I
boss?
know how to do that.
The perimeter of a rectangle is 2 times the length plus 2 times the width. The area of a rectangle is length times width. The perimeter of a full circle is 2 pi r or pi d. And the area of a circle is pi r squared. We don't have a full circle though, we have a half circle. What? Yeah. So if we want to use a half circle, we're gonna do 1/2 area of a circle and 1/2 perimeter of a circle. So let's do the area first, because we want to make sure we don't count some of the stuff for the perimeter. The area version, the area, we've got 10 inches times 6 inches. That's my rectangle portion. And then we've got 1/2 for the 1/2 here. pi r squared, and I don't know that I identified r here. So d is the full distance across the circle through the center. D is for diameter. R is for radius. And 2r equals d. And we have d is 6. So 2r equals 6 inches. So r equals 3 inches. So I have 3 inches squared there. So my area is 60 inches squared, or square inches, plus 9 pi over 2 square inches. Or, since it said use 3.14, we have 9 over 2 times 3.14. Let's do that real quick.
Is pi equal to 3.14?
No, but we're using an approximation.
2, 6, 5, 3, 5, 8, 9,
So if you're like,
2, 3, 4,
How did that
6,
change? How did that change it?
When did you ever use it?
Oh.
4, 3, 3, I can keep going. Go.
I'm gonna use the wavy symbol rather than the equal sign. 74.13 square inches. This is the approximately sign. Once we change from pi to 3.14, the exact value was lost. We are now using an approximation.
We had a question.
Did we?
We did, we had a question. X to the 0 power is what?
You never know.
Is it?
Yes.
Who says 1? Is it 1?
Anything to the 0 power is 1.
Anything to the 0 power is 1?
No.
Except for.
Get your TI, you get your Casio out, and
No.
tell me what 0 to the 0 power is.
Except for, wait, with the exception
Yeah,
of-
you said anything you
There
said,
was
type
no
it in.
definition.
0 to the 0 power.
Would it be one to anything in the?
Well, type it in, you tell me, 0 0 power, what does your calculator say? Tell me 0 0, who says 1? Yeah, now that I've made a big assertion about it.
Mr. Reddy? There's like a lot of numbers. What are the chances that X is zero?
There's a ton. 0, actually, the probability of X being 0 is 0. So there's a little bit of a twist here, as long as X is greater than 0, right? The fine print that nobody ever reads.
What about less than?
But I want an explanation, why is 0 to the 0 like causing my calculator a problem?
5 times 5 times 5 is 1.
0 to 0 is not a problem for you. What does your calculator say 0 to the 0?
It's near
That depends on how the calculator calculates 0 to 0, or tries.
Domain, so your calculator says domain, what does that mean?
You know this exponent topic is coming up in a little while, right?
So what else? What's 25 divided by 25? Break your calculator out, 25 divided by 25, what do you get?
Do not break your calculator out for that. How do you teach this shit saying get your
Get your
calculator?
calculator out, 25 by 25, what do you get?
1.
So what is 5 to the 0? 1, right? So what is 0 squared divided by 0 squared? So on your calculator, what is 0 divided by 0? So if you want to use the same rules, 0 to the 0 power is the same thing as 0 over 0? Yeah, does that blow your mind? On a Tuesday in the middle of summer? 0 to the 0 power is like looking at the sun. Do not look at the sun.
Don't tell me what to do. I'll look at the sun if I want to.
I will be covering all the
You
exponent
said
rules.
1. You are, it's too late. For you, it's 1.
I said, you didn't let me finish, I was gonna say except for 0. And anything negative, of course.
He's getting bored, and I knew it was gonna happen, so it's okay.
That was a question.
That, he was asking the floating teachers walking around helping.
Oh.
Know your place, Mr. Reddick. That's right, that's right.
Put his foot down.
Check and mate.
What about the negative number to the power there?
It should still be 1. I don't know that pickiness of the x greater than 0.
Yeah.
We haven't had the perimeter yet here. So our perimeter part, I'm actually gonna label the big picture. This is 10 inches here. And this is the perimeter of a half of a circle. So what is that? Perimeter of a half a circle. We said a circle was pi d or 2 pi r. We already have d, so that's what we started with. Let's go with that, 1/2 pi d, 1/2 pi times 6 inches. And we got 3 pi inches. If we use the approximation that we were told to use, this is approximately 3 times 3.14 inches, which is 9.42 inches. So that's this distance right here. And so if we're looking for the perimeter of the big shape, the bullet, we have 6 inches plus 10 inches plus 9.42 inches plus 10 inches. I'm just going around the edge. And what we got, 35.42 inches? I'm doing that in my head. There's a chance that's wrong. Find the value of x.
Yeah, exactly. I did the same thing like yesterday. I did the same thing yesterday.
So that's a problem.
Yeah.
You're not even understanding it.
Now, if we knew the perimeter of the triangle, we could do this really quickly, right? This is quick if we know the perimeter. But we don't. So instead, we have to use Pythagorean's formula. A squared plus b squared equals c squared. We'll see what falls out from that. C is always the longest side on a right triangle. You can label these A and B or B and A, however you like. They're the two legs. A and B are legs. C is called the hypotenuse. So we'll just plug and play. X plus 2 squared plus x squared equals x plus 4 squared. Remember that this, we don't just square the components. That means this.
You can't just square the components?
No,
Everybody knows that, right? Everybody knows that, can we do that?
Oh, yeah.
Yeah, that's wishful thinking, nobody's ever in my class.
you're gonna lose points if you have some shit like this.
You do that in my class, you're gonna go to math jail, do not pass go. How many times have you done that in your life? One time?
I got yelled.
You got yelled at?
There's a traces class too.
What is it really?
A squared, B squared,
plus 2ab plus.
Or Or you just distribute real quick and don't memorize the formula. You can memorize the formula or just distribute.
Or you just use generative AI.
Or just use generative AI.
Calculated with an integrated AI.
You open your phone, you search ChatGPT, and then you search Ableton.
Since we have squared, we're gonna gather everything on the same side.
Sirens outside, man, please come here.
And we have x squared minus 4x minus 12 equals 0. Yes, because I subtracted everything on the other side and there's nothing left over there. Because that's how we solve quadratic formula. Anytime we got an exponent greater than 1.
Let's keep you on your toes.
I have Carlos's approval. I am apparently doing a sufficient job. That's high merit. Carlos is a good student. The same merit from Redden just doesn't go as far. All right, so what do I do here? It's been a while. We have a couple options. Factoring is the desirable one. The goal is we want to have something times something else, and then times something here plus something here, if we factor. They could be different. Having an x and an x squared here means it should have an x and an x. This is called the guess and check method. Then we want two factors that multiply to negative 12 and add to negative 4. There's also a third method that I like better than those, is the table. And I'm gonna do the table here.
I don't even know how to do that, so factoring is so hard.
Well, this is easy.
What's the table?
The table method here is we're gonna do a multiply column and an add column. And we're going from negative 12 and negative 4. And the starting step takes a little bit of reasoning. If I want to multiply and end up with a negative number, what has to be said for the two numbers that are multiplied together? One is positive, one's negative, right? Which one's the bigger number? The negative. The negative's got to be the bigger number because when we add them, it needs to be negative. So I'm just going to go with negative 12 and 1 right away. These add to negative 11 and that doesn't work. Then you can try, well, just keep going down, or better, keep going up here. Raise this by 1, this is 2. This has got to be negative 6. These add to negative 4. I'm going to keep going because I want to illustrate something that you'll see as a pattern here. I could keep going 3, 4, 6, and 12. This would be negative 4, negative 3, negative 2, and negative 1.
Sorry, Mr. Jones, what was the original x squared minus 4x?
Yes. And we already found it. But I want to illustrate the power of the table. That the diamond approach and the square doesn't really help with. If I add these together, I get negative 1. If I add these together, I get 1. If I add these together, I get 4, and I get 11. Do you notice a pattern here? They're not only are they the same, they're symmetrical with the sign change, but it's increasing going down. So if we get to a problem that doesn't factor, I'll put one up in a second, and you're going through it and you do this table approach, increasing this value one at a time for things that work, and your addition thing passes the number you're looking for, your target, it doesn't factor into whole numbers. Does that make sense? I'll show you where it doesn't work in a second. But we found what we were looking for. The diamond method also works here. We wanted this.
So you just try all the combinations until you get your middle term. So basically, you're guessing anyway.
No, I'm following a rigorous pattern here, and
Oh, the pattern, I see, yes.
I'm following a pattern, and if I pass the number that I need, I stop. I don't need to guess anymore,
I see,
okay?
I see.
Now, the shorthand approach is just dropping these in here. This only works when there's no coefficient on x. The better approach that will always work we are going to split the negative 4x up into negative 6x plus 2x. And then we're gonna do by grouping. This is, here we group those, we can factor out an x. Here we group those. That should be a minus. I can factor out a 2 and we'll have an x minus 6 here. And notice the x minus 6 is on both. So we can factor those out and it leaves behind an x plus 2, which is what we had up above. Now, we got a whole nother section in a little while that's on factoring where the leading coefficient or the coefficient on the variable with the biggest exponent is not 1. This shorthand approach only works when it's 1. This will always work. And this is always a times c, where we have ax squared plus bx plus c equals 0. And this is always b. We'll do a harder one with different things later, yeah.
How did you know that it was negative 6x and plus 2x when you split it up and decided to factor out?
Because I use these values right here.
Also, you still have to use the table with.
Yeah.
Okay.
Just guessing on all this. So how does the diamond method work? I don't even know.
It's like guess the things that work.
Do you know the diamond method? I put the 1 here.
On one side, you're supposed to do
like the 6, well, the top side is multiplying, so you multiply the ends of the equation. I can't,
You'd have the negative 12 on top.
Yeah, negative 6.
Do the diamond method right here.
right there.
We know the answer. I don't know the diamond method, so it's like I need someone to tell me.
it's 2 numbers multiplied to.
So you gotta think of 2 numbers? So you still have to find, still gotta guess on the 2 numbers?
Yeah.
It's guessing, and this is guessing, it's all freaking guessing anyways.
I don't know, that's a box method
Force it
you're talking
into
about?
I don't know these methods, so that's what I'm saying, I don't know.
The box method's pretty good.
Show me the box method.
So you use the cross method or the diamond method when the leading coefficient is 1.
Minus 1.
And so we would say you have 2 numbers that multiply to negative 12 that add up to negative 4.
Oh, okay.
Those 2 numbers are negative 6 and 2.
So you guessed
And so
that.
then x minus 6, x plus 2. I mean, you guess, yeah, if the numbers are more if these are composite numbers, which means they're not prime numbers, if they're higher, bigger, like 24 or something, then you're gonna have more factors to guess and check. But then this is actually a pretty methodical method for when the leading coefficient is not 1. But that I still use when we're gonna get there at some point, but when the leading coefficient is not 1, but it's a prime number, I still use guess and check. But if they're composite numbers, then I start going into the box method because there's a lot more.
Show the box method.
We need an example with the leading
Oh, you
coefficient.
need a leader coefficient for the box
Yeah, I
method?
mean, so
Leading's
what
one.
you do is you multiply the leading coefficient times the last number, that becomes the number in the top. And then this middle number, then you need 2 numbers to add up to that. And then what you do for the box method, say for example, I don't really,
X squared minus 6x plus 5.
that's still leading coefficient 1.
Oh, shit, you're right. 2x squared minus 18.
2x squared minus 18 would be a difference of squares approach.
You
But
can-
we
it
can
still
still
works.
do it, yeah, we
Still
can still
works.
do it. 2x squared minus 18?
That's one I could pop in my head real quick.
Yeah, again, easiest, not, math, well, I always say mathematicians are lazy, we want the easiest way to get there. And I would not use the box method here. You want to factor GCF first, always with polynomials. That means if there's a number that you can factor, you want to factor that out, you get rid of that. Because if this is equal to 0, yeah, I can factor a 2 out or divide everything by 2. You get an easier thing. I'll just get x squared minus 9, difference of squares. But if we're going to do this, then it would be like this. This is not, it is not really good, probably not a good example, but you multiply the first number by the last number, which is negative 36, and we need it to add up to 0 because there's no middle term. The coefficient of the middle term, it would be 0. Two numbers that add up to negative 36 would be negative 6 and 6. And then over here you would do like 2x and x, because that's how we would get 2x times x.
You wanna know when that works?
Yeah, let's do another one.
4x squared plus 15x plus 9.
Okay, that's a good one. 4x squared plus 15x plus 9. We use, this one, I would use this box method because both the leading coefficient and the real number at the end, the constant, are composite numbers, which means that the factors could be like for 4, 1 and 4, 2 and 2, this one's 1 and 9, 3 and 3, but it could get worse if they're higher. But anyhow, 4 times 9 is 36. Now add up to 15, and 12 and 3, I guess is what it is?
You're guessing.
Yeah, 12, yeah, you are guessing, you are guessing. 12 and 3, and then once we do that, we go, let's see, you put 12 and 3, it doesn't matter which one you put here, I believe, let's see.
My friend usually divides the leading coefficient between the 12 and the 3, and then you can solve for your, like, an equation, so it
The
would be like
leading
x
coefficient
equals-
between the 12 and the 3. Oh, I
So
see,
like the 4 divided by like the 12 and the 3, and then she like, I don't know how she does it, but
Yeah.
she puts it into like the,
it's been a while since I've done this, but what you do here is you put 4x squared there, and I believe you put 9 there, right? And then the 12x in this corner and the 3x in this corner. Okay, and what you do here is you look down this for a GCF, like what do they have in common? Well, these both have a 4 in common and an x in common, this is 4x. What do these have in common? They both have a 3 in common, this is 3. Now going across, same thing, what's the GCF here? Well, they just have an x in common, and what do they have in common here as well? A 3, right? So that's how you would factor it. This is 4x plus 3 times x plus 3. And again, I usually use guess and check method if we're dealing with prime numbers, because say this was a 3, then you're forced to be the 3x times x to get that. So, and then you would only have to guess and check with the second number, but still, this is a methodical approach. I teach it for like algebra or whatever,
Right.
but.
I'm doing the table version on the screen at the same time. I went 1, 2, 3, they both had to be positive because it's a positive number and it adds to a positive. And we end up with 3 and 12. I split it here, the 15x splits into 3x and 12x based on that. Then I group again, and I can pull out an x here, and this is 4x plus 3. And I can pull out a 3 here, and that's 4x plus 3. And 4x plus 3 is on both. You got x plus 3, like that.
Yeah, one thing to note though, when you're factoring by grouping, if this is negative, you have to factor the negative out, right?
Yeah.
So, and then also the same idea, if you've been taught the box method, if this one's negative or this one's negative, the GCF must be negative. Only if the first
Can
one
I
is.
demonstrate how you would get the final thing with the diamond thing?
Sure.
Really just remember how to do it. So you take the leading coefficient and you just like drag it down to both here. And then you divide both of these. And if the coefficient doesn't like divide properly into this, then you would take that, and that would be the coefficient from here. And it's plus 3, right?
Yeah.
And then since this does properly divide into it, just have it plus the 3. So you just take the,
you would like technically solve for like a 0 on one side, so it'd be like x equals 3, and then you would have a negative That's why I was like, I need to get this serious.
I don't know, I just remember just having to plug in these.
So in calculus, when you get to calculus class, that's where we're all going, right? Okay. All this stuff is for like newbies and beginners. In calculus, I don't wanna see any of this crap. This is all garbage, and don't ask me, I forget how and all this, but if there's this, you do that, if there's this, you do that, I don't know any of the rules, I don't give a shit. I need you to be able to factor it, period, end of story, don't ask me. It's hard to factor,
And it doesn't always factor.
takes a lot of practice,
It
it doesn't always factor.
You can always use a quadratic formula, even if it does factor.
Yeah.
So, I mean, that always works. So sometimes when the leading coefficient and the real number, the constant are so bad in numbers, it's not obvious the way they factor, if they do at all. It just saves the time and just goes straight to a quadratic formula.
Why the hell do we even need a factor to begin with?
Well, because it's faster and it's easier, and I don't like pulling in my calculator. So, we're lazy, we want the easiest, fastest way of doing it. As long as the answer's right, that's all that matters.
And sometimes we want the factored equation because we're still using it, and a lot of students struggle taking solutions and putting them back into the equation. At this point,
There's a lot of room for error too, using the quadratic formula.
you set each one of these equal to 0. We'll do the quadratic formula in a second. For this same problem, solve for x. And I would argue with the problem that we were looking at, recall we're finding the values of x. Only one of these solutions is valid. Which solution is valid? And why? We can't have a negative distance, right? And that would say this distance here is -2. So that one is out, x equals 6 is in. If we were doing the quadratic formula, it's based off of this format here. X equals -b plus or minus square root of b squared minus 4ac all over 2a. We had x squared minus 4x minus 12 equals 0. So a equals 1, b equals -4, c equals -12. We do some plug and play. X equals 4 plus or minus square root of 16 plus 48 over 2. 16 plus 48 is 64. This ends up being 4 plus or minus 8 over 2. And we get our x equals 6 or x equals -2. That's a quadratic formula.
How do you get two solutions?
It's a graphical thing. It's easier to see graphically, and we're gonna do graphs in another day or so. So hold off on that question.
You answered. I mean, what are two values of x that make that statement true? Those are the two values that make it true. For the context of that problem, it has to be positive because the distance is only measured positively.
Yeah, the exponent is the number of possible solutions. The largest exponent, I should say. And what we're doing here is finding the zeros or the roots. And that's easier graphically. I did want to show you guys something else where the table thing, something that could make it real quickly to show you if it doesn't factor. Let's say we had x squared plus 37x plus 180. I deliberately chose something that has large numbers. And I'm pretty sure that it's not gonna factor. it needs to multiply A times C is 1 times 180 or 180. Needs to add to 37, which is B. They're both negative or both positive because the outcome is positive multiplication. They add to a positive number, so they're both positive. So 1 and 180 is 181. 2 and 90 is 92. 3 and 60 is 63. 4 and 45 is 49. 5 goes in 36 times, I think. 150 and 30, yeah, and that adds up to 41. 6 goes in 30 times and it's 36. 37 was right here, we passed it. Doesn't factor into whole numbers or into integers. So that's where you're forced to do the quadratic formula. The table eliminates the guess and check, especially like if you've got a big number like 180, like you're going through a lot of combinations and you could have an answer that worked. Like if I had 36, I may have just given up on the guess and check method before I got to 36. But if you're doing the table format, you actually are following a pattern and you'll know right away if it doesn't work. Well, not right away, but maybe right away, depending on what B is. That's the advantage of that, because the quadratic formula, while it works, there's a lot of room for fucking that one up, and you gotta, you're not doing this in your head, you're writing this shit down, and yeah. So like, ideally, you're not doing that. Let's see. I jumped ahead to get to the factoring. Oh, a couple more things we were gonna do. Factoring is a little bit ahead, but we've covered a good chunk of it now. Find the distance between 2 points. We'll go with -2 and 3 as the x and y coordinate for the first one, and 4 and 1 here. Now graphically, what's going on? Is we are finding this distance right here. And there's a formula for the distance formula, but it stems from this graphical version of it where we can make a triangle. And if we call this x1, y1, and this x2, y2, then this distance here would be c squared. This number here has got the same x coordinate as that one, x1, but it's got the y coordinate of this one. So this point right here is x1, y2. So we got a squared plus b squared equals c squared. The distance, so let's call this a and b. A is, the x value doesn't change. The y value is just y1 minus y2 or y2 minus y1 squared. B is this distance right here. The y values aren't changing, but the x values are. X2 minus x1 squared. And we've got c squared. And you just take the square root of both sides. So the distance formula is really giving us c here. Is the square root, and we generally put the x's first. How does it work with our problem? We just label points 1 and 2. So you can call whichever one you want 1 and whichever one you want 2. I'll call this 0.1 and this 0.2. The distance is x2 is 4, x1 is -2, y2 is 1, and y1 is 3. I have the square root of 6 squared plus -2 squared, which equals square root of 36 plus 4, or square root of 40.
Done, walk away, circle it.
Don't do that.
Go to 40.
Now, if you want a decimal answer, you'll get a decimal answer with a calculator, but otherwise you want to simplify it.
Why don't you make it, you take out, because you take out the 10 and it's 10 times the square root of 2.
You mean doing something like this? Like I was about to?
Yeah.
I just hadn't gotten to it yet. I'm going step by step in the calculation.
You were gonna circle the square root of 40. I
No,
saw you. You were
really?
like, done.
Radicals work, we can separate the radicals like this, and square root of 4 is 2. So the best version of this is 2 root 10.
What if I just did the decimal in calculus and did square root of 40 and just gave you the decimal, would that be okay?
No, unless your teacher says decimals are okay.
Decimals are not okay.
Your teacher will specify whether decimals are okay.
Decimals are for commoners.
Decimals are for, Love that.
The decimals.
decimals, the problem with decimals is they are an approximate answer, which means they are wrong. An approximate answer is really wrong. If we go another decimal place, you're missing a value.
Hey, does that mean that everyone who uses money is wrong?
What do you mean?
Money's decimals, so.
When you approximate to a decimal, a number that actually has a decimal in it is fine. 9/5 is 1.8 when you divide.
I didn't hear the prompts that, I only heard decimal.
That's because you have selective hearing. And Redden's in your ear playing, I don't know, devil? Weaver.
So if the number isn't irrational, then make it a decimal.
If the number,
Consequence free.
yeah,
If you can.
irrational means it can't be made into a ratio.
Yeah, so you're not gonna take off points if I write 1/2 is 0.5.
I probably wouldn't, but some teachers might. Sounds like Redden would. As long, but no, if he did, that's wrong. Because 1/2 and 0.5 are identical. Pi is not 3.14,
It's 4.
22.
but 1/2 is exactly 0.5. It is not an approximation. If you have to round, let's specify that. If you have to round, it is no longer an exact answer.
And exact is better, right?
Exact answer is the only thing that matters. It is an approximation.
And then the next step.
Now, in real life, even in the sciences, when you're building shit, eventually you need to approximate. You cannot cut a 2x4 to be 2 roots 10 long in length. That doesn't help. You're gonna have to turn it to a decimal number, and you're eventually gonna have to round somewhere and figure out where you're gonna cut it. So in real life, applications will define how long or how many decimal places you need. Science is when you've got things like Planck's constant and you're dealing with things on the atomic level and stuff like that, you want a lot of decimal places. So like, you're better off not rounding. But that's the distance formula. Did you have anything else you wanted to add, Mr. Red? I know that he's distracted. Keep him busy.
Give me a laser pointer.
Find the volume. (6 meters height and the diameter is gonna be 4 meters. This problem is we were looking at the volume of a cylinder here, right? And at first glance, you're like, I don't remember the volume of a cylinder. Let's break it down. This is a circle, and it's really just a bunch of circle discs. And if I make the height 1 on all of these, then I can just treat the volume as just the circle. So the volume of a cylinder, we've got pi r squared for the circle part. And the part that makes it a cylinder is actually the third dimension, which is the height. This is what gives us third dimension, is our height. So the volume of a cylinder is pi r squared h. So we can use that to our advantage here. That is h. I can see it right now. This is d. And we already said d was 2r. So I've got 4 meters equals 2r. Divide by 2, and I get r equals 2 meters. The volume is pi times 2 meters squared times 6 meters. 2 times 2 times 6 is 24. Pi meters squared times meters is meters cubed. If we wanted an approximation, because that's not helpful, we'll use 3.14. And you may be going like, well, where the hell is this helpful in your life? We have a lot of cylinders in life. Your soda often comes in a cylinder. Gas gets transported in a cylinder. Doesn't it? And then like how much gas can the gas truck carry? We can find out. So there are uses for cylinders and stuff. If you don't know a formula and can't figure it out, you should always be able to look it up. A teacher in general is not going to give you a problem on a test that uses a formula they have not covered in class. In general, at least at the community college level. If they don't, or if they do, it was a lapse. We all make mistakes. All right? Are we having fun?
Yep.
Good.
The papers are not up there.
What do you want?
I just want a piece of paper.
Well, come up here.
The white papers are inside.
Oh, let me take
Solving equations, we already did some of it. We want to, the goal in these is isolate the variable. Like Redding at a bar, looking for a partner. Gonna try to get her alone, get her drunk. The guy never walks up to the group of girls and tries to get one of them. You gotta get her alone. You gotta talk to her alone, because otherwise, they're not gonna talk to you. You don't have a chance to get the girl.
Like prey mentality or whatever. Like, you know how like
The way I phrased it was predator-prey mentality. But that is in general not necessarily, there have to be a predator-prey thing. I made it that way because I used Redding as an example. predators and prey do it all the time. The pack isolates the weakest of the pack, or what they're hunting, and takes it down. Take down the young, take down the weak. But I made it creepy by putting Reddit in a bar. The way I said it was creepy, if you don't think it was creepy, maybe that says something about you. Alright. If we've got parentheses, we gotta deal with them first. So we will distribute the -5. And there's still more factoring later. I will cover that negative thing and having a negative come out for the grouping symbol later on. So I did distribute it here. I will combine like terms on the left side. 12 and -5 is -3. We want to isolate the variable, which means either move x's left or move x's right. So one option here is I can move all the x's to the left. I can do this by subtracting 2x from both sides. And then I want to get x alone, I will add 3 to both sides. And then I will divide by the coefficient. And I get x equals 2/7. Alternatively, we can choose to move the stuff to the right. Add 5x to both sides. And while I'm at it, I'm gonna add 5 to both sides to do these 2 steps in one. Now I divide by 7, and I still get x equals 2/7. The benefit of moving it to the right in this circumstance is I don't have a negative coefficient. You will be surprised how many points you're gonna lose over the course of your educational career just because of having a negative sign there. It happens to the best of us. And when I say best of us, I mean even Weaver.
It's happened, it's happened once or twice,
It's happened.
off the record.
I only got one perfect test score here at COS when I was a student here. I got a lot of 99s and 98s, and a lot of those points were lost to fucking up the negative sign. Whatever you do, if you can solve a problem where you have less negatives in it, it's beneficial. Because it's really easy to see like, -4, that's not a good one. Let's see this, -4/5 x equals 1. If you have the negative there, it's really easy to think maybe not negative if you're distracted. It's part of the fraction.
Yeah.
You know what I mean? It just looks like the pin like got lifted for a second. And so like just avoid negatives if you can.
Did you tell them about yourself? Did you know Professor Jones was actually a student here?
Yeah.
He was a student here and went through the whole 9 yards, Mesa and everything, you told him?
No?
Oh my God.
I mentioned that I was a student here, but
And you went through the whole 9 yards, I think you see.
I actually started in Algebra 2, we don't offer anymore, which is basically college algebra. I started in effectively Math 35, I took 54, I took
started
all the
at the bottom.
calculus,
Did the Mesa thing.
did the Mesa thing while I was here, went to work, got an internship at NASA while I was here. I was the only student that applied for the first NASA scholarship program. Dr. O shared it with everybody, but no one else wanted to do it. I'm like, this sounds awesome. And I did it, and I got to go to NASA, and I came back with a NASA t-shirt, not a NASA t-shirt, but a NASA polo, I'll wear it tomorrow.
An experience.
And some experience to put on my resume and stuff like that, ended up getting NASA scholarships. I got a lot from being part of the MESA program here. It's good that you're already,
Now he's a professor here, so maybe someday that'll be you good.
and
You
yeah,
know what your goals are? But being a college professor's not a bad gig.
Tamara's walking that route herself.
Oh,
She was a student here. And she's now working on being a math professor. She hopefully replaces Redden,
Gonna replace me?
hopefully.
It's gonna be tough.
No, you're gonna graduate sooner than he retires, so let's say it's not
Oh, I'm
Redden.
so retiring tomorrow?
You are not.
It's a big shoes.
I will find where you live and drag your ass back to school. You are not leaving all the seaside to me.
We need a computer science instructor, so hurry up and graduate.
Just hold on.
Hurry up. You got
I'd be a
it?
math instructor.
We need instructors.
Let's kick it up a notch. Who here likes working with fractions? You are all goddamn liars.
I prefer I way prefer decimals, more accurate.
I didn't say if you prefer it over decimals. I definitely prefer fractions over decimals. I don't like working with either, and if you do, I think you're deluding yourself. Jones says this. Jones says fuck fractions. Multiply by the LCD to clear fractions. We looked at LCD earlier. I'm gonna write the three denominators I have, 3, 4, and 6. I'm gonna write them in factored form in a table here. And I'm gonna make all the columns just have a unique number in them. 3 is just 3, it's prime. 4 is 2 times 2. And 6 is 3 times 2. The LCD is 1 from each column. 12. I am going to multiply both sides by 12. Remember to distribute. I'm showing it the long form just in case people like to do it this way. I need to put a wall up here. If you multiply by the LCD, this number, the LCD is always going to cancel with part of that. You should be doing that. This turns into 4 times 2x minus 3 times 3 equals 2x plus 3 times 21. You can actually see what that multiple is going to turn to by what's left on the table. This had a denominator of 3. That 4 came from 2 times 2. The denominator of 4 was missing a 3. That turned into this 3 right here. And the 6 was missing a 2, and that turned into that 2 right there. You don't have to do the table though. Just use the LCD, it's the easiest one to do. At this point, we've got 8x minus 9 equals 2x plus 63. I will isolate the variable where I have a positive coefficient. So I will subtract 2x. And since I hate wasting paper, I'm going to add 9 to both sides at the same time. And I get 6x equals 72. Divide by 6, and I get x equals 12. How can I know I got the right answer? We haven't mentioned this before, but you can always check your work. The beauty of math, in almost every single problem, you can check your work by evaluating the solution in the original equation. Don't do your cleaned up form, go back to the beginning. 2x over 3 minus 3/4 equals x over 6 plus 21 over 4. If I put my 12 in, what do I get? This is gonna have some decimal stuff going on, right? I'm checking it at this point. I plugged in the 12s there. I have 24/3 minus 3/4 equals 12/6 is 2 plus 21/4. I'll leave it in that form real quick. This 24/3 is 8. If we want to compare them, just get a common denominator, multiply the 2 without a denominator by 4/4. And I get 32/4 minus 3/4. Does that equal 8/4 plus 21/4? We should get 29/4 on both sides. So x equals 12 did work. Any questions? If you're interested in NASA and you're in the MESA program, Dr. O and I both get emails from NASA when they're doing their program, which happens every semester. And I think as long as you're enrolled in Cal 1, you are eligible.
Doesn't even need to be that, if you have like, this minimal, it's like 12 units of STEM courses.
Okay.
You're eligible, and a letter from a recommendation letter from the professor.
What you do with it during your time there as a?
The next topic is gonna be inequalities, which is gonna take a while. We only got 9 minutes left. And I worked at NASA for 2 summers, but while I was a COS student, what it involves when you're at COS is they give you a project to do while you're taking summer class, or not summer classes, but your regular classes. You'll work on a project. I was designing a mission to Mars, like when to launch, the cost, what's gonna go on there, what the objectives were. And then you're submitting stuff every couple weeks. And this was for me, it's different now. And you're getting graded, like you're judged every week, but there's like a bunch of us doing it. And basically, as long as you did a good job, they invited you out to NASA for a 3 or 4 day project. I went out to Houston and met a lot of people that I still talk to on Facebook. And a lot of them aren't affiliated with NASA, but some of them are. And one of them recently even applied to be an astronaut. I don't know if he's gonna be an astronaut, but that's a couple year process for them to determine. That's how it started here, and from that, when I transferred, I got internships and scholarships with NASA, and got to work at Ames Research Center out near San Jose. The first time was at Sustainability Base, which some of the students walked by. I don't know if you guys got to tour this last spring. It's a base that's like a moon base, except it's not on the moon, obviously. The window's open, which makes it not fit for the moon, but it generates all of its own electricity. It recycles like 98% of its water. And I was working there on how to help optimize the building so it saved energy. Using stuff I learned at COS. And the second summer, I worked at the aeromechanics branch, which is, they cover flight. NASA isn't just about spacecraft, but aircraft and helicopters. I was working on helicopter blades. If you take Cap 1 with me in fall in Tulare, you're gonna learn about it. I'll show you images and some of my work. But it all started here.
So in your time here at COS, this is what you probably wanna work on, super important. The surgeon gonna need recommendations.
Yep.
That means not being shy, laughing at all my jokes. Talking to your professors, coming to Friday Night Lab, participating in MESA, getting to know me and Professor Jones and Dr. O, you can get those recommendations a little easier.
That is really key. He's not emphasizing really how important that is. The student that sits in the room that's quiet, that only ever spoke to, say, here on the first day, we don't know who the hell you are. We met you and heard your name once, 4 months ago, even if you asked at the end of that semester. But if you're asking 2 years later, you've said your name once and it was 2 years ago. I don't know who the hell you are.
and experience on start building your LinkedIn resume. You know, so all the projects that you do, you can list them, or the volunteer opportunities, you can list them on your LinkedIn and start building that, start thinking about it. This is super important. Gotta be able to work with people and talk to people and interact, have fun, and then of course that comes with connections. So these things you gotta start working on.
And when you ask for a recommendation, ask if they can write you a positive recommendation. Positive, don't just say recommendation. Cause if they don't know you, a good teacher will be honest and say, I can write you a recommendation, but it may not be the one you want. I don't know, I can't say enough that's gonna be beneficial to you, or like recently I had a student that didn't do well in my classes. I think the student was a great student or will be a great student, but when he asked me for a letter of recommendation, I said, I can write you one, but I don't think you're gonna want it. I mean, like, look at your grade history with me. I think you're gonna be successful. And I can put that, but I also have to put, you didn't pass my class. If I'm gonna write a letter, I gotta give all the facts.
So are we gonna do, is Mesa gonna do a LinkedIn workshop?
I have no idea.
Start building your LinkedIn? 98% of HRs look at it.
I don't know about you, but I get things on LinkedIn every once in a while. Hey, you're a math professor, would you like to come work for our company? And I get it all, like, maybe once every 3 months I get a job offer on there. Like, you have no idea how happy I am. Captive audience, I get to tell stupid, corny jokes.
And well, the thing is also, when you need a resume or something, or you need a recommendation, you can print out your LinkedIn or give a link to your LinkedIn to me, and then I can go there and see what you've done, and I have more to write about.
There's
You have
that.
like an ongoing resume if you do it, it's just easier. How many of you have LinkedIn? About a third of you, yeah, you have nothing at first, you're gonna have nothing at first. That's why you're here, you start building it. Lots of volunteer opportunities, I think.
Or if you're sending a letter or an email to the teacher and asking if they'll write you a letter of recommendation, maybe say a little bit more about, just reminding them who you are, but say, this is what I want to do, this is where I'm trying to transfer to, or whatever I'm trying to accomplish. That way we got a little bit more about you, and we tell them what semester and year you took the classes with them, if it's been a couple of years. I get emails still from students from 6 or 7 years ago that are well past COS asking for a letter of recommendation because they know I'll write them a good one. And that I remember them, they even update me on their progress, what they're doing now. But if you give the person you're asking some information about you, we can write a better letter. Oh, that rhymed.
I had the FBI come to my house 4 days ago.
I love that you are so, he is so dramatic.
You guys are like assuming. I did not run to the bathroom and start flushing stuff. No. They knocked on my door and a student was trying to put my name in to the FBI because they're getting a security clearance. Thank God I knew the kid from Friday Night Live and stuff.
What did they do?
From Mesa, they're working at Boeing and they needed a security clearance. And so to get that security clearance, you have to have a recommendation from like your instructors and people you know and stuff.
Oh, your FBI story is much better.
So that was my FBI story 4 days ago. It was just basically a recommendation.
I had the FBI at my door, and it was for all the wrong reasons, but it wasn't for me. They
Oh,
were not looking for me, but it didn't mean I was innocent.
I was just, I can't believe you guys are thinking that way.
Really? Drama club, you deliberately phrased
It was a
it that way.
recommendation.
Theatrics.
A lot of jobs require that security clearance. If you can get that security clearance when you're an intern, you get an internship. I was talking about the NASA internship, my daughter came through COS. She had the NASA internship, and so when she was an intern, she got the security clearance as an intern.
She took this program, she did the math jam.
Yeah, she did the math jam, and but in particular, that security clearance was very valuable for her. So she works at Lockheed now. And
What's the,
if you could get that clearance as an intern, that would be very, very, very helpful.
I'm brain farting, what's the government one that's crypto?
NSA?
Yes, NSA, I've had the NSA call me, they didn't show up at my house, but they called me for a recommendation for somebody, and it was thorough.
Oh, the NSA.
They were very thorough on what they wanted to know about the individual. And I believe he got the job, because I haven't heard from him since, which means he's probably working for the NSA. They drop from radar real quick, you can't be like a public or no Facebook.
Verifying that you're talking to someone from the NSA.
I know, right?
Like-
I would not believe it. It's like,
They're
on the
like, oh,
phone.
let me pull up the stuff we've listened to, in your conversation so you know it's us.
So the FBI verification was easy, they had badges, when they opened the door.
They referenced places I knew him from and asked what it was like to be around the person and like how much contact I had with them, and like they named stuff that
So you knew it was
they
real?
could have. I could have given it to a complete stranger, it could have not been the NSA, and he could have been captured by some terrorist group, I don't know, I assume it was the NSA.
So this is a big question, what's for lunch?
Oh, yeah, what is?
That is a good
what
question,
is-
it's 11:30.
Yeah. What is for lunch?
What is, I know, that's what I'm saying, I don't know.
It'll be next door, whatever it is.
Is it lunchtime?